Hello everyone. So, we will continue with the psychological scaling system. So, in last class we have discussed there are 4 different types of psychological scaling: nominal scale, ordinal scale, interval scale and ratio scale. We have discussed the nominal scale, which actually talks about the equality. Okay. Like we have mentioned that wool if we give 0 and silk we can give 1, that means all silk we have to give 1 and all wool we have to give 0. That means 0 means equality in the characteristics. We cannot differentiate. Okay. We can only differentiate between wool and silk, then we tell our characters. So, within wool we are not able to differentiate. So, nominal scale is a very simple one. So, we just differentiate between wool and silk. So, within wool there may be 100 different types of wool, but nominal scale, as we have mentioned, it is a 0 is as a wool. We cannot stop there, we cannot differentiate between wool 1, wool 2, wool 3. Okay. For that it is a next scale which is called ordinal scale. Ordinal scale takes care of equality as well as relative position. Like equality means like nominal scale, it is a here just like a nominal scale, it takes care of, it is a separate out wool as 0, silk as 1, but within 0, within wool it will talk about the relative position. That is the second level. Like it is a class, in a class say 10th class 11th, 10th you just we can give it as A, or 11th it is a B. So, as per nominal scale 10th means A, we cannot, but ordinal if we talk, then it will actually give as per rank or marks, it will give you 1, 2, 3, 4, 5, 6. So, it ranks the student, it is relative position of the student. So, this is called, it is a ordinal scale. Like if we take the example of textile material, like earlier material. So, wool was 0 and silk was 1. Now, within wool we have say 10 different types of wool, we want to differentiate. So, 0 is wool, then 0 and difference in terms of softness or hand feeling. Okay. 0 softest, 0 harsh, like that we can rank. Okay. It indicates the relative position of the objects as per the softness level, which one is top. Okay. Like that. But the magnitude of difference of the object we cannot measure, it is not the magnitude of the object. Like say we have 3 different types of wool, wool 1, wool 2, wool 3. Wool 1 is the very soft, there is a medium soft and it is a harsh, wool 3 is harsh. This much it can tell, okay, the ordinal scale. And silk also, silk 1, silk 2, silk 3, but it cannot tell that okay, difference between wool 1 to wool 2 or wool 2 to wool 3, whether it is an equal difference it cannot tell. How much difference it is there, it can. So, this scale only gives the, it is a ranking. Suppose in the softness scale the cotton gets the rank of second. So, what we are doing, we are trying to rank of the all the available fiber in our lab. So, we have got the wool, silk, cotton, polyester, all the fiber. So, that is the we are trying to rank. So, rank scale, the in the softness the cotton gets the second rank and polyester gets the 10th rank. So, as per this ordinal scale we cannot say that cotton is 5 times softer than polyester. Okay, difference it cannot say, it cannot identify the difference. It only ranks the item from highest to lowest, okay, that much ranking it will give you. Okay. So, what we can do? We can actually use some non-parametric statistics. What is that? Mode or median we can use, but mean we cannot. Like if we want to rank which fiber is at the middle as per the softness value, that we can give, but we cannot perform the mean value. Similarly, hierarchy in an organization, like top president and a vice president, like that, we can rank it, okay, depending on the rank of the in the organization. After this ordinal scale, next scale is that interval scale. What interval scale says, that it determines the equality like our nominal scale plus its relative position, the ranking is there, and then it talks about the magnitude of difference. It is the interval scale, it takes care of the magnitude of difference. Its magnitude should be same, it will tell. Okay. Best example is that it is a numbers are used to rank the objects or events numerically equal distance of the interval scales represent equal distance in the characteristics. So, another thing is 0 is not fixed here, this has got 0 and their unit of measurement are not fixed. Okay. It indicates the relative position of the object and the magnitude of difference between the objects. The most common example is our, if you see, that is box and blanket technique which we use the 3 factor 3 level box and blanket. We use the code, the it is a -1, 0 and +1 level. 0 does not mean it is absolute 0, it is a level, but here we can say the difference between -1 and 0 and +1 of a particular attribute, it is same. So, this is the magnitude of difference is same. Now, we can see like wool fiber we are taking, with softness we have measured, at different level of softness we have measured. So, 20, 30, 40. Okay. So, 30 being the center, we code it as 0 or we can use 20, 30, 40. So, that way the magnitude of difference should be same, but here one catch is there, it is a 0, it does not mean it is absolute 0, 0 it is a scale factor. For example, 0 degree Celsius is not an absolute 0, okay, but 0 centimeter is an absolute, because 0 centimeter length is an absolute length, but 0 degree Celsius is not absolute 0 temperature, it is in a Kelvin, it is absolute. For example, if we talk about say 0 degree Celsius and say it is not 10 times warmer than 0 degree Celsius, it is not 10 times warmer, it is a reference in between, but the intervals are equal. Here the intervals are equal, but no absolute 0 value, this magnitude of difference is equal. So, here 0 is not absolute. So, perception wise we will not get 10 times warmth than 0 degree Celsius or 1 degree Celsius. So, that perception wise it is not same. The scale is not only classified and ordered of measure, but in the order of measurement, but also specify the distance between each interval on the scale. Okay. So, this is the thermal scale. Okay. Thermal scale you can give excellent, very good, good, poor, worst. Okay. This way we can give some particular point. Okay. So, this way we can and last one is the ratio scale. Ratio scale talks about the equality, relative position, magnitude of difference and with a meaningful 0. It has to have a particular absolute 0 value like Kelvin scale. So, it has an absolute 0 value like 10 degrees Celsius is not twice as hot as 5 degrees Celsius, but 10 degree Kelvin is twice as hot as 5 degree Kelvin. So, if you have absolute 0 value, then you can compare like 10 centimeter is double to that of 5 centimeter. It has got absolute 0 value. Okay. So, if we see in tabular form, it is a totality. If you see nominal scale, it determines only the equality. Okay. It categorization and classification. Okay. It only categorize. Wool is 0, silk is 1. It categorizes. And what type of statistics we can use? Count, we can measure the count, mode or percentage, chi-square, this type of statistics we can use. Ordinal scale, what is there? It determines the equality and relative position. It can rank the objects and different types of like median, ANOVA, 2 ANOVA, this type of statistics we can use. Then interval, it talks about the equality, relative position, magnitude of difference, and the we can use it is used in say index numbering, attitude measurement, perception measurement. So, interval we can use. Perception means it is a warmth or cold, this type of perception measurement we use interval scale. Okay. Mean, standard deviation, all this type of statistical tool we can use. Ratio scale, it determines the equality, relative position and magnitude of difference with meaningful 0. Okay. So, entire statistical performance we can do. Okay. Next is that another type of scale, it talks about the rating scale, and this rating scale is extensively used in market research. It is one of the most important method which are frequently used for subjective evaluation. There are two types of rating scale. One is called comparative rating scale, another is non-comparative rating scale. Okay. Now, so these comparative rating scales are again subdivided by paired comparative rating scale. So, paired comparative rating scale. So, what does it mean? We will have pair, okay, A and B, then we can compare. I will discuss in detail. Then rank order. So, we do not have the pair, we have one single item, okay. Then we can order in terms of rank, that is rank order comparative rating scale. So, comparative means you have to have more than one attribute, one object like wool. So, wool and silk, we have two type of fiber. So, when there is a pair of objects, so we can use paired comparatives. Like we have 10 different types of wool. So, there what we will use comparative scale, but in rank order, So, we can order wool 1, wool 2, wool 3 like depending on different types of subjective assessment. Okay. Then constant sum. So, we can have particular different perception and then we can add the perception value and then we can totally get the constant sum. We will discuss in detail. Then this is comparative. Comparative means more than one object should be there, but non-comparative is that we have single object, one particular garment, okay, a garment, and I have to actually rate in terms of say thermal comfort and all. So, in that case we can use the non-comparative scale, okay. And comparative scale is we can use where we have more than one object. Okay. So, non-comparative scale, it is a continuous rating. So, we can have at a continuous scale we can just use a particular value, and itemized rating scale, non-comparative itemized rating scale is again subdivided into 3 types. One is Likert scale, staple scale and semantic differential rating scale. So, this we will discuss one by one. So, comparative rating scale, as we have discussed, it has got 2 types. In this scale, some standards are provided, that means we have to compare to the respondent during rating time for comparison. So, we have to have one standard, then we can compare. So, as we have discussed, it is a paired comparison, rank order and constant sum. So, here we have to give one standard, then the respondent will give the response. Paired comparison, respondent is presented with 2 objects at a time, it is a paired of object. So, then only he will tell this is soft, this is hard. Then asked to select one object in the pair according to some criteria, like 2 garments are given, tell me which one is warm, that is paired. It is used only when few items are compared. So, you cannot use this paired comparison for say large 1000 different types of articles are there, we cannot use this type of only few articles are, then you can compare. For example, comparison, compare the softness property of cotton with polyester or wool with polyester, then only this type of paired comparison can be used. So, and he can only tick which one is softer or which one is warmer. So, it is used, one thing is that it is a first as one standard has to be given and less number of variable items should be there, and he will only compare. Compare based on pair. Next is the rank order. Respondents are presented with several objects simultaneously, like wool is given. So, 10 different types of wool or 3 different types of wool garment is given, and he is asked to rank in terms of particular order, particular, then asked to rank them according to some criteria. For example, rank the following wool according to their softness. So, the wool 3 different types of wools are given, wool 1, wool 2, wool 3, then he has ranked wool 1 as 3 rank softness, wool 2 has got 1 rank of softness, wool 3 has got 2 rank, but 3, what does it mean 3 here? Is it softest or harshest? It is soft or harsh, that we have to actually specify, we have to tell. For it, if it is soft, very soft, you give it 3, or if it is very soft, you give it 1. So, these things you have to give in detail. That is called rank order. The respondent has to only rank the wool, different types of wool. Third one is that it is a constant sum. So, what is that? This is the, it is a comparative constant sum. So, again we are comparing with the something. Respondents are asked to allocate a constant sum of units among a set of stimulus objects with respect to some criteria. So, we have fixed some criteria. Suppose we have 2 different types of wool, wool 1 and wool 2. The criteria which has been actually described, you give thermal, fineness and softness, 3 criteria is explained to him, and you give the rank order, you give the value out of 100. We can set, you can tell it is a arbitrary, we can tell you give on the basis of 10 scale, if you want a very detailed result or a very sensitive result, so you can increase that value. So, here say 100, with the 100 scale you rank wool 1 and wool 2 in terms of thermal scale. 100 means best, suppose 100 means best. So, thermal scale he has given, so 76 for wool 1 and 70 for wool 2, fineness 88 and 84, softness 90 and 95. Okay. These are the scale. Now, if we assume these three are the three, thermal, fineness and softness are the best parameter to judge the characteristics of wool, then we will use 3, and if we feel some other parameter has to be incorporated, we can keep on incorporating. Now, then we will simply add constant sum. So, what is the total value of these attributes? 300. So, out of 300, wool 1 has got this ranking, wool 2 has got this ranking. So, then we will add this value, then we will tell okay, wool 1 is good or bad. So, higher value means better. So, wool 1 has got, say as per thermal sensation it has got higher than wool 2, but softness it has got lower than wool 2. So, but we cannot tell it is a softness wise it is more, or it is not that, it is you have to sum, you have to add. So, then based on this addition we can tell okay, this is the. So, this is called constant sum A, it is a comparative one, comparison between wool 1 and wool 2. Then comes to the non comparative. Here we do not have any reference, no standard value. Here what we will do, we have a single object. In this scale no standard reference is provided, okay, for rating. This scale can be categorized into two ways, one is continuous, another is itemized non comparative rating scale. So, what is continuous rating scale? Also known as a graphical rating scale. Continuous rating scale is also known as graphical rating scale, like this one. We want to have comfort, softness or thermal sensation for a particular garment. So, in actually in market research this is very widely used, and respondents are asked to actually rate, to rank this value in terms of comfort. You just select this for a particular garment, you select 80, 75, 90. So, for even garment 2 you rank these things accordingly it is. So, there is no comparison. So, suppose for a particular garment we take say 100 respondent. So, they give all this value, then we use some statistical technique to arrive at certain value. Okay. So, this is the continuous one. So, then comes to the itemized non comparative rating scale. The respondents are provided with a scale that has a number or brief description associated with the category. So, these are of actually different 3 different types of itemized A. So, these scales can be of 3 form. One is called itemized graphic scale, like for comfort you just graphically it can say this is a favorable graphic, this is indifferent, it is neither comfortable or not comfortable, and it is a unfavorable, it is a discomfort. So, this graphical picture we can use this one itemized scale, or it is a verbal, and this is most widely used itemized non comparative scale. So, verbal it is completely satisfied, like if in terms of comfort you can say it is a very comfortable, moderately comfortable, it is neither comfortable nor like this. Okay. Similarly, itemized numerical scale. So, we can use numerical value -3, -2, minus. So, we can use any one of this. Okay. So, this is itemized non comparative rating scale. So, these are of actually different type. So, 3 different types. Likert scaling, it has got actually, it is designed to study how strongly respondent agree or disagree with the statements, and we can use 5 to 7 scale. Like this is the Likert scale, it is a depending on the agreement or disagreement. So, if I tell it a strongly disagree, it is 1 disagree. Okay. So, this is if we want to have this type of study, then we have to use Likert scaling. Staple scaling is that it is a vertically unipolar rating scale with 10 categories rating from -5 to 5 +5, but 0 is not taken. So, like this one, it is a 0 point, it is a without neutral point. Okay. So, -5 to +5. Okay. And third one is the semantic differential scale, it is 7 point rating scale -3 to +3 with 0 point. So, 0 point or 1 to 7 we can use this with end points associated with the bipolar level. Like end point is bipolar, one side it will be soft, another side it will be hard, smooth or rough, cold or hot, these are the bipolar rating, and in between we can tell. So, this is, that means there is no confusion. Earlier you have to define, okay, 3 means whether most comfortable or least comfortable. Here it is given that it is 3 means extremely soft and -3 means extremely hard. So, bipolar labels are already given here. Okay. Now, there are, based on all this scaling method, there are different studies carried out. So, we will mention here a few examples. Hollis used a number of itemized rating scale for sensation, for perception of different types of perception. Like it is a 4 point scale he has used, like 1 is 4 is partially, mildly, 2 is definitely, and 1 is totally. So, similarly these are in comfort level. Okay. Similarly, on a 5 point scale he has used, it is a 1 is totally uncomfortable and 2 5 is completely comfortable. So, in this way Hollis used this type of rating scale. Another is that comfort affective labeled magnitude CALM scale, which is used in US Army Natick Shoulder Center. Okay. So, what they have used? They have used that rating point at the range of -100 to 100, where -100 represent its a greatest discomfort imaginable, -100, and +100 is that it is a greatest comfort level. So, this is a CALM scale. Another scale is used as McGuinness thermal scale, okay, where it is used in 13 intervals, okay, scale, where the same laboratory they have used. So, in this way, like 1 in McGuinness thermal scale, 1 means I am so cold, I am helpless, it is a 1 means it is a defined, okay, and 13 means I am so hot, I am sick. Okay. So, that means all these labels are given, labels are expressed in terms of what? Expressed in terms of some sentence, some value. Okay. So, while rating, a person will put himself in that rating scale, and gradually it will give say 5, 6, whatever scale it will be giving. Okay. Similarly, CALM scale, it is a 100 means greatest comfort, 100 plus 100 means greatest comfort, and minus 100 means greatest discomfort. So, accordingly one can actually put himself. So, these scales are also used, and in thermal comfort, psychophysical scaling of clothing comfort, another comfort scale is used, which is called category scale, which is actually one type of rating scale, is the most commonly used subjective scale. Okay. the category scale is exactly like rating scale. We can just rate that extremely comfortable, moderately comfortable, slightly comfortable or extremely discomfort. So, this type of ratings are given, like, or in terms of number we can also give. So, category rating scale is actually the person can rate his subject comfort sensation by placing him into the several descriptive category. Okay. Since less than 5 categories, if we can use say 5 category or 3 category, he cannot discriminate. So, distinguish between the two sensation. So, better is that to use more number of categories, at least 7 categories are actually suggested. So, the main advantage of the category scale is that it is a simple, versatilely used, okay, and higher reliability. So, category rating scale we can use. These are actually of two types. One is the number category scale, like we have used earlier in rating scale, and descriptive category scale. Okay. Number 1, 2, 3 or descriptive category scale. The main problem of category scale or particularly number category descriptive category scale is the it is called category end effect. Means very interesting. So, if I am put in a situation where I have to scale, it is in a say 1 extremely comfortable, then comfortable, moderately comfortable, slightly comfortable or extremely discomfort. Okay. 1, 2, 3, 4 or another 5. So, 5 or 7 scale. The main problem is that in category age effect is that the person will normally do not like to put him in extreme point. He would try to avoid himself rating as extremely comfortable or extremely discomfortable. That means, the category age effect results the 7 point category scale being functionally reduced to 5 point. So, 2 points are reduced and 5 point scale reduced to 3 point scale. So, the common problem with the category scale is that the normal tendency of a person is to avoid the end categories. So, that is the biasness. Okay. So, that is the main problem with the category. So, it is said that category scale we should use large number of categories, then age effect will be minimized. Okay. Now, we will discuss the now we know the scaling pattern, okay, what different types of scales are there, how to scale, all these things we have discussed. Now, we will discuss the another way of measuring the psychological or psychophysiological clothing comfort sensation is the wear trial, which is actually most widely used in measuring the clothing comfort. Okay. Why do you use wear trial? Basically, if we measure the fabric characteristics, cloth characteristics based on the objective measurement or subjective measurement, we will not get the overall sensation. Okay. And the perception of sensory clothing comfort involves various sensory channels: visual, auditory, smell, taste and touch. So, this all these things we can only get if we wear the cloth. So, wear trial technique means it says that it is you have to wear a total complete cloth and then we get the sensation. Okay. That means, out of all this sensation, that means skin plays an important role to sense the comfort level of clothing. Now, the fabric properties, mainly the type of fiber or yarn, fabric structure, fitness of the garment, these are very important, which is actually which controls the which actually affect the wear trial response. Okay. Next is the environment, temperature, relative humidity and the wind velocity. So, for during wear trial we have to set the particular environment, humidity. So, that means if a particular fabric, particular garment we develop from fiber, yarn or fabric, but if we change the temperature, that means total sensation will be different. If we change the humidity of the climate, it will give us total different sensation. So, we have to specify the environmental condition, then only we can get the correct value of correct response as well as the activity level. So, these three parameters are very important, because at different level of activities our sensations are different, we generate different types of sensation. So, that is why this activity level is extremely important. So, for any wear trial technique we have to define our clothing or garment, we have to define our environmental condition and we have to define our activity level, then only we can get the proper response of a particular person. Okay. This is the basic design of the wear trial technique, and the main purpose of wear trial is to gather information from the respondent at a garment level. We cannot get the wear trial in the fabric level. Okay. At the proper garment level we get the perfect information. So, therefore, the wear trial is an important technique for comfort research, clothing comfort research. Okay. Various sensory attributes, descriptors are generated from the response of the respondent, okay, and we get the information. Okay. And this is only possible during the wear trial. Okay. And psychological scales are designed. So, after doing all these things like our garment selection, environmental selection, activity selection, then we have to design the psychological scaling system. Okay. So, according to the predetermined protocol, you have to define the protocol, then wear trial technique you have to conduct the wear trial technique and collect the data. So, this actual necessity of the actual wear trial, why do you need wear trial? Why can't we have only the objective testing data and get the value? As we have mentioned that wear trial is very important, because that we get the particular overall sensation only after the wearing the cloth, only after the actual activity, only at the actual environmental condition. Suppose I am trying to develop a cloth for extreme cold, okay, and if I measure only the thermal transmission or moisture vapor transmission or air transmission, it may not give the exact comfort level of a person at that say minus sub 0 to minus 30 degree Celsius, minus 40 degree Celsius temperature. It will not be able to give, we will not be able to simulate that situation. Okay. So, for that we have to develop cloth, we have to generate that environmental condition, then only through wear trial we can get the actual sensation. Suppose the fabric is thermally it is perfect, okay, but touch wise it does not give proper sensation, proper then we may feel discomfortable. So, to generate reactions of wearer to any perceived discomfort sensation produced by the different climatic condition. So, that we try to get the all this discomfort level at different level of activity, different climatic condition, we try to get this value. This is only possible through the wear trial technique. So, the different external stimuli and physical activities. So, different types of external stimuli, heat, moisture, wind, all this combined effect we get. Okay. These stimulations are normally generated under specific conditions like softness, mechanical stimulation, what is softness, scratchiness, prickiness. This only we get at particular condition, like wool. If we wear wool and cloth at cold condition, we may not get the pricky sensation. Pricky sensation we will get only at the warm and sweating condition. That only we can get this type of sensation, mechanical stimulation we can get, or thermal stimulation we can get only in wear condition. Okay. And sweating rate, physical activities. So, if I start walking, I will have different types of physiological perception, psychological perception of that because of the different physical activities. Okay. Fitness of clothing, like clothing, if it is tight fit or loose fit, my total perception or total sensation will be different than if it is tight fit. Okay. So, different type. So, these are only possible in wear trial. Okay. That is why wear trial is very much necessary. Like environmental condition, even if the temperature changes or humidity of the environment changes little bit, total sensation, keeping all other activities constant, only by changing the humidity or air velocity, my total perception will be different. So, we have to design very carefully depending on the actual application of the clothing. Okay. Now, what are the steps that we have discussed? We have to generate the sensory attributes, okay, of the wearer. So, all these steps of wear trial we will discuss in the next class. Okay. Thank you.